In this video, we will be looking at logarithms. Here's something that you're already familiar with. 2 to the power of 3 equals 8. This just means if I multiply 2 by itself 3 times, I will get 8. Now, I can ask you a question, or I can write a statement where I'm asking you what that exponent is, and it looks like a log. If I write log base 2 of 8, I am asking 2 to the power of what gives me 8? And the answer to this log is 3. So the answer to a log is an exponent. When you see a log without a base, like this, log x, it means the base is 10. This is called a common logarithm. So if you see log 100, it's really log 100 with a base of 10, which asks the question, 10 to the power of what gives me 100? And that is 2, so this log is equal to 2. Let's practice first converting between logarithmic and exponential form, and then the other way around. So when I see y equals log base 3 of x, or log x base 3, however you'd like to communicate it, the base of the log is 3, and that's going to be the base of the exponential. The answer of the log is the exponent, and then you have x. So it's like you're doing a little cycle, or a little spiral. 3 to the power of y, so that's power, equals x. And I can do it to the next one. 3 to the power of 4 equals 81. Next one, the base of the log is 2. The answer of the log is 4. That must be the exponent, equals 16. Next one, log of 1 over 8 with a base of 2 equals negative 3. Well, that's 2 to the power of negative 3 equals 1 over 8. The base of the log is the base of the exponential. The answer to your log is the exponent. And then you have the answer to the actual exponential expression, which is the 1 over 8. Let's go in the opposite direction. Y equals 5 to the x. I want the logarithmic form. Well, I'm going to have log. The base of my exponent is the base of my log. The exponent is going to be the answer to my log, and then that just leaves y. So log y base 5 is equal to x. Next, log, our base is 6, just like in the exponential form. The exponent is 2, so that must be my answer. And then there's my 36. 10 to the power of 3 equals 1,000. The base is 10, which I can write if I want, or I can leave it blank. It's implied. The exponent is the answer, and then 1,000. So log 1,000 equals 3, or log 1,000 base 10 equals 3. And final one, 3 to the power of negative 3 equals 127. This is a good time to remind yourself that a negative exponent can become positive when you take a reciprocal of the base. So 3 to the power of negative 3 is actually a third all to the power of 3, and that's where that 1 over 27 is coming from. But going back to our logarithmic form, the base is 3, the exponent is the answer, and there's the 1 over 27. And I'm just going to put that in brackets so that we don't think it's an exponent of 3 or it doesn't look out of place. Let's actually evaluate some logs without a calculator. So when you see log base 4 of 64, you're asking the question, 4 to the power of what gives you 64? And this kind of looks like an exponential equation at this point. And if we think back to last year, when you solve an exponential equation, you're trying to get a common base. I know that 4 to the power of 3 is 64. So I'm going to replace that 64 with that. And there we go. Once our bases are the same, our exponents are set equal to each other. So I was looking for that question mark. Well, there it is. So log 64 base 4 is equal to 3 because 4 to the power of 3 equals 64. Next one, log of 1 over 100. I am asking the question 10 to the power of what gives me 1 over 100. Now I see that fraction, I'm already thinking of a negative exponent. When I see the 100, I'm thinking of 10 to the power of 2. So 1 over 100, combine that, 10 to the power of negative 2. 10 to the 2 gives the 100, the negative gives that reciprocal. So our log is equal to negative 2. Next, I'm asking 5 to the power of what gives me the square root of 25? Well, first of all, I can simplify the square root of 25, and that's just 5. And now I'm just asking myself, 5 to the power of what gives me 5? Well, that's just 1. Next, the question here is the base is 2, so 2 to the power of what gives me 8 squared? Well, 8 squared is 64, so I'm actually asking 2 to the power of what gives me 64? Well, I know it's 2 to the power of 6. That gives me 64. So there we are. Let's get a little fancier with our simplifying. Add some fractions, add some more exponent rules. Log of 1 over 27 base 3. So we're asking 3 to the power of what gives 1 over 27. Well, I know 3 to the power of 3 is 27, but that's not what I want. I want the reciprocal of that, so let me put my negative exponent. And there we go. The next one, I see log base 3 of this expression, 9 times the 5th root of 9. Well, the first thing I would want to do is clean this up. So I'm going to take this out here. This is 9 to the power of 1 times 9, and think back to radicals and rational exponents. The 5th root of 9 is the same as an exponent of a 5th. And now I have the same base of 9 attached by multiplication. The exponent law is add the exponents. 1 plus a 5th, get your common denominator. 1 is just 5 over 5. So when we add them, that's 6 over 5. So now we're really asking the question, log base 3 for 9 to the power of 6 over 5. So this asks 3 to the power of what gives me 9 to the power of 6 over 5. Well, that 6 over 5 isn't going to get cleaned up. I can't apply that to the 9 to get a nice integer value. But I can get a common base because I know 9 is just 3 to the power of 2. And now I can clean that up. When we have a power to the power, we'll multiply our exponents. So we end up with 2 times 6 over 5, that's 12 over 5. And that's what our expression or our log is equivalent to. Our final example, we have 2 logs that we have to simplify, and then we'll just add those values together. So I'm going to do them in 2 steps here. So log of a third base 9. That's asking 9 to the power of what gives me a third. Well, I know that 3 squared is 9, but I need to get a common base of 9, not 3, because my question mark is above the 9. Well, I know the square root of 9 is 3, and square roots can be seen as rational exponents, specifically a half. So 9 to the power of a half would give me 3, because that's just square rooting 9. If I want the reciprocal of 3, I'll just add my little negative exponent. And there we go. So log of a third base 9 is negative a half. Now I'll do my other log. 3 to the power of what gives me 1 over 9? Well, this is a nicer one. I know 9 can be written as 3 squared. If I want it to be 1 over 9, I'll add my negative exponent. And there we go. So I'm doing negative a half plus negative 2. Get yourself a common denominator. Negative 2 is negative 4 over 2. And then do your simplifying. And there we are. Last little question here is to solve a logarithmic equation. When you have a logarithmic equation and it's not similar to that simplifying style, a safe idea, if you don't know where to start, is try to convert it to exponential form and see if that's going to help you. So log x base 6 is equal to 3. So 3 is the exponent. 6 is the base. 6 to the power of 3 equals x, and 6 to the power of 3 is 216. There we are. The next one, remember, invisible base of 10. 10 to the power of negative 4 equals x. Negative exponents mean reciprocals, so this would be like 1 over 10 to the power of 4. And then 10 to the power of 4 is 10,000. So 1 over 10,000. Next one, base is 3 to the power of 4 equals x. That's 81. And finally, our base is 125. The answer is the exponent, so a third, and it's going to equal x. There's that rational exponent again. I'm thinking of a root, specifically a cube root, which asks, what to the power of 3 gives me 125? Well, that's just 5. So there we are, converting between exponential and logarithmic and the other way around, simplifying logs, solving some basic logarithmic equations, and that's it.